Alright, these are the notes on Unit 3 of Chapter 1. This is operations on sets and on statements. So, this is going to be about unions and intersections of sets. Almost always these are going to be visualized using Venn diagrams, everyone's favorite thing from elementary school. Start off defining what an intersection is. So X would only be in the intersection of, which is what this symbol is intersection of set A and set B if and only if, which is what this means, IFF, if and only if, X is in the set of A and X is in the set of B. So basically means if it's in A and it's in B, it's going to be in the intersection of A and B. And then X is in the union. This is easy to remember because U for union. Let's set A and B. If and only if X is instead of A or X is instead of B. So it doesn't matter if it's only in one of them, as long as it's in one of them, it will be in the union of A and B. So a way to visualize this, Mercury, set A, actually we'll do 3. So we'll have set A, B, and C. Erase this stuff up here. It's getting a little bit crowded on the whiteboard. So let's say we decided to say X is in the intersection of A and B and the union of B and C. First off, we would find, okay, A and B, so that's any spot that's in the set of B, and the set of A, which we can see lines up with the A and B part. So it's going to go here, and the center part, so here. And then we can erase this extra stuff. Figure out. So it has to be in blue. And then the union of B and C, so anything in B, so that'd be all this stuff, and anything in C, so all of this stuff. So that would be anything red or green. So they have to figure out, does this be in the intersection of A and B, and it has to be in B or C, so all this red or green area. You can figure out, well, the blue part, which represents this, falls under the red for throughout all of it, and it falls in the green here, so it's always going to be under the union, so we can state that it will just be this whole chunk falls into that. Our schedule example, X is in the intersection A and B, set A, B, so just figure out blue for set A, green for set B. Where is it both green and blue? Let's give me this middle part. And that was the intersection, is just the middle part of the Venn diagram. And you can do this with as many sets as you want. Make it really messy, like the previous example, or really neat like this one. But the logic holds up the same for all of them. And from the visualizations, we're able to derive a few rules about how unions and intersections of sets work. So like a lot of laws from arithmetic hold up. Like for example, the distributive law. You have the union of set A and the intersection of set B and C. That's should be a C. This statement is the same as the union of set A and B, the intersection of set A and C. And this can be seen as distributing the A union over here and over here, kind of like in math. Like with numbers, you have 5, 3 plus 7, that's equal to 5 times 3 plus 5 times 7. This also holds up under something like the intersection of the union of B and C, or instead it'd be the intersection of A and B, as well as the intersection of A and C. And this follows roughly the same logic. Additionally, the associative laws, like you have this string set up with the intersection of A and B and the intersection of that between C. It's the same as if you switch the parentheses over. The order of the parentheses does not matter, and it's the same also for unions. And then the most intuitive of the laws that holds up is the cumulative law. A and the intersection of A and B equals the intersection of B and A, as well. This also holds up for unions as well. Oops. And then on top of that, there's two logical statements that we're also going to be working with, because like we've thrown like and or as terms, but then we can now mathematically quantify them. We have this little symbol, it's just like a triangle. This equals and then this like thing looks like a V. This equals or. However, this is an or in like the standard English tense. Like if we had 1 or 0, this could be the results we could get from this that would be valid would be 1, 0, or we could also have 1 and 0. It doesn't mean one or the other, it means one or the other or both of them. So then like you can go back to like the rules that we had at the beginning, like for example, x is in the set of the intersection of A and B if and only if x is in the set of A and x is in the set of B. Parentheses here. Instead of using and, we got the little triangle thing. Also, the formal name for it is a conjunction, I think. Probably wrong about that. Yeah, it is a conjunction, and also this symbol is a disjunction. So as long as it has something, it's valid. I think that is all of the notes on this unit. Bye.